Hey guys, welcome to another video. Today we're going to be talking about this beast of a battery build. This is a 72 volt 80 amp hour build consisting of Samsung 50G cells. So those cells are 5000 milliamp hour, 10 amps discharge each. This is 20S16P, so about 160 amps of continuous discharge. That's what it's rated for. Probably should do a little less than that. But we're going to show you exactly what goes into building a battery pack like this. So when we're approaching something like this, we want to make sure that 1, it fits, 2, that it's built properly, and 3, that it's going to be as safe as possible. So we've even got things like the BMS, very nice active smart balancing BMS. We've got the breaker that's built right in. We have everything is separated with cell holder separators. And the very first thing that we do when we start off with a battery like this is we take a model and we scale it. So as you can see, we've got the frame and then we've got a measuring tape in the same picture as the frame, and we're using a CAD program to be able to measure how much of a battery can fit. And we actually have a free online mini course that shows you exactly how to do all of this on your own for free. And you can check that out in this link right here. But so what we're doing is we're trying to see how many cells we can fit into this frame. And for this pack in particular, when we're looking at it, it has 320 cells. So there's 160 cells on each half. And then once we have those 160 cells, we make a basic model for it. And then we're going to hop on Alibaba and we're going to get some custom copper plates for this pack. So basically we share this model to one of the copper manufacturers, and we tell them what our configuration is, and they're going to give us a printout or a drawing that looks just like this. And so as you can see, it's got all the different plates on it, and that's what we use to construct this battery. So a battery like this, a motorcycle battery, obviously takes a lot of consideration, but the process isn't that hard to do, and we're going to show you everything that's involved in building a beast of a battery like this in today's video. So check it out.
So the first step would be laying out our cells in the 2 halves of the pack. So this would be 1 half put together, and then this is the second half. And then we need to lay out our cells so we have our negative on one side and then the positive on the other side. So let's get to it. So this is going to be the first half of our pack, and this is a layout for the first half, and then we're going to follow the same layout for the second half. But when we do weld it, on the first pack we're going to make these 16 cells, the negative terminal, and then when we do the second half and we weld it, on the second half we're going to make this side the positive terminal. Okay, so now we're going to spot weld the first half, and on this first half, like I said, I'm going to make the first 16 negative cells my negative terminal, and we have these CNC pre-cut copper plates that will flow a lot of current throughout the pack, so they're pre-machined, so I just need to lay it out and then weld it, and the pattern's going to be like this. And I need to make sure that none of the copper pieces touch each other like that when I'm welding it, especially once one side is welded. It's going to arc on the other side if I do, so this process needs to be done very thoroughly and carefully. Okay, so when I'm laying out my copper plates, I'm just going to tack them on with just a couple points on just a couple cells for each plate, and then once I tack the other side on as well, then I'll weld all the cells on. The reasoning being is if at any point the copper plates do come into contact with each other, it'll minimize the arcing since not all the cells are connected. So I've welded one side of the pack, and one thing to make sure is you want to check to see if all the cells got welded to make sure you didn't miss a cell that you didn't weld. And then another good thing to do is once you weld one side of the pack, put Kapton tape, protect this side in case a metal piece can goes through and arcs two of the groups together. So if you put some Kapton, protect it, and then weld the other side, you should be good. Next thing I will do is I will put some glass tape around the pack, fiberglass tape, and then bond the pack together, and then put a layer of Kapton and then fish paper insulation underneath so this flap can fold over, and then the cells will be protected from it. The first half is done. Now I'm going to do the second half of the pack. The cell layout is the same, but how we're going to weld it is going to be a little different. So I'm going to start out with my positive on this side and then lay out my pieces like this. So the first 16 positive cells are going to be my positive terminal, and then I'll connect the other cells in groups and then lay out my pre-cut copper pieces. And then same process, tack them on first, tack the other side on, and then fully weld the pack up. So before I put the two halves together and connect it, I'm going to prep each half by putting solder points on each of the tabs where the balance leads will go, and then we'll be able to put the two halves together and make it one pack. So right here we have a fiberglass panel which we laser cut to the shape of our battery that'll go in between the two halves. And how we got here was we used our solid model of the battery, and then we made an outline of it and turned the outline into a DXF file, and then we used our laser cutter to cut this panel out. And obviously if you don't have the tools for that at home, if you can get a rough cut of the battery shape and then put it in between the two halves, either using fiberglass panel if you have it or some sort of cardboard, that would be great. So before I bond the two halves together, I'm gonna cover up the outside surface with fish paper too, because we're not gonna be welding or soldering on this surface. We already have our tabs here that we're going to use. So now I'm going to bond the two halves together using fiberglass tape. One good thing to do is maybe clamp it down using a clamp so it stays together. And then I will use fiberglass tape. Don't clamp it down too tight, just enough where it'll stay together. And you can use fiberglass tape on the side and then do some loops to make sure it's really secure. Alright guys, so we're going to continue on with this battery. I've flipped it upside down so I can connect this cell group to the other, which will connect the two halves together. And to do that, I'm going to use this copper sheet that I've cut out to length to the size of the pack, and then I'm going to solder the copper piece on both sides using solder, and it should connect both halves together, allow plenty of current to flow through the pack. And so let's get to it. Okay, so this process is done. Now I've connected the two halves using the copper sheet, and I've just used solder to basically put it on there. And now we can flip the battery over and continue on the other side with the BMS. I'm going to cover this side up with Kapton tape and then fish paper, so this connection is protected, and then I can continue on the other side. Alright, so what I'm going to do next is, before I put my BMS on, I'm going to add a negative discharge wire, and I'm going to combine all these wires and then solder it onto my 8 gauge thick wire that'll be going out as discharge, and then I can put the BMS on. That way it'll be easier rather than putting the BMS on then soldering these wires on. So guys, one thing that would really help you in this process is having a big soldering iron like this one. It would kind of be hard to do this with a smaller one, so we do have this giant soldering iron that provides a lot of heat, and it'll help all the wires melt together. So I've shrank over the part where I solder connected this 8 gauge to all the 6 wires off the BMS. And then I've added some Kapton and fish paper to protect my positive terminal in case these do touch the negative and the positive. And then next thing I'm going to do is I'm going to glue down this BMS. So this BMS is a good up to 22S, and it can do 425 amps peak. And we will put this BMS on, and then I will glue it down here. Then I will solder on each of my 6 wires to this negative terminal, and then I can do my balance leads after. One thing I made sure to do was leave at least a little gap between my negative terminal copper plate and my BMS. Since the BMS is metal, if they come into contact, this whole BMS turns into a negative. So you don't want to do that. You want to leave at least a little gap, but mostly away from the positive and then a little bit away from the negative terminal. Okay, so now I've soldered all my 6 battery negative wires onto my negative terminal, and now I can do my balance leads. Alright, so this BMS comes with 4 sets of temperature leads, and then I'm gonna make little openings and put them right onto cells. So I ideally put 2 on this half the pack and then 2 on the other half the pack. You can use some little bit of glue to hold that temperature sensor in place so it stays right beside the cell. Okay, now I'm gonna wire the BMS, the balance leads on the BMS according to the diagram that's given with the BMS, and I will go to each group, not use the 12th lead, and 2 leads go to my 12th group, and then I will continue on with the rest, and then the last 2 leads go to the positive. Okay, now I can cover up the balance lead sides with some fish paper, protect it, cover up the negative terminal with some fish paper, then I will continue working on the pack. Okay, so this is the BMS app, the ANT BMS app, and then now I've activated the BMS, set it to 20S, and as you can see, it's reading all the groups, and the delta voltage is very good. It's 0.002. You want it to be ideally under 0.010, and now I can continue on with the rest of the pack. The next step I'm going to do is I'm going to splice in a smaller charge wire for the negative, and then I will put my positive wire. It's going to be pretty short because this end is going to go into a breaker, and the other end of the breaker is going to have another 8 gauge wire coming out, which will connect to our QS8 connector and match with these this negative wire. And then I will also put a smaller positive wire for charge, and then we will put a XC30 connector as the charge connector. Now I got my positive discharge wire, as this end will go to the one side of the breaker, and then I will have another 8 gauge wire that's coming out of the breaker, and these are my charge wires, which will go to a XT30 connector. I will cover up this positive terminal with Kapton tape and fish paper, protect it, because this negative wire is going to be running right beside it, so you never want them to come into contact with each other. And I will put the XC30 connector on and put the pack on charge, and then we will do a discharge and make sure everything is good before wrapping the pack up. Alright, so the next step before the final step, which would be putting on the connector of your choice, would be to enclose the whole pack with fiberglass panels to offer protection against impact. So here I cut out 2 of my fiberglass panels to the shape of the battery using a laser cutter. Obviously, if you don't have that tool at home, you can cut it by hand too. And I've cut these different panels, different size panels, to go along the side of the pack. So I will put all the panels together, bond it with fiberglass tape, and then I will finish off with this blue insulating glass tape at the end, and then finish off the pack. We've wrapped up the pack with blue glass tape, which will insulate the pack and then hold all our fiberglass panels in place. And then the next step would be to put our breaker on. So this end, you're just going to strip it and then run it into the one side of the breaker, and then just screw it in. Okay, and then you can glue the breaker on in place here. The final step that you would have to do is add a 8 gauge positive discharge wire and a connector of your choice. Usually we like to put these QS8 connectors on our packs, but in this case we're going to wait for the customer to tell us what connector they want exactly. And that is the end of the pack, and hope you guys enjoyed the process and hope you enjoyed the video. Alright guys, there you have it, your 72 volt 80 amp hour pack. I hope you enjoyed the build process and learned some things. And if you have any comments or questions, please drop a comment in the comment section below. And I hope you enjoyed it.
And make sure to let us know what you want to see from this channel. We're definitely community driven, so we're taking those comments and we are running with them. Also, be sure to follow us on Instagram at Electric Bike Laboratory. We're starting to post a lot on there. We really hope you guys enjoyed this video. Be sure to subscribe because we are giving away a prize for every 1,000 subscribers that we get to, up to 10,000. We've already given away some pretty cool stuff. So definitely drop a comment, subscribe. We are giving it away to a comment. So we're selecting random comments and giving the prize that way. Guys, thank you so much for watching. We really hope you enjoyed this. And definitely remember, keep it on two wheels. Thank you guys so much for watching this video. Make sure to drop a comment. Let us know what you think. Let us know what you'd like to see. We want to hear about it. And if you want to watch another video, click on this one right here. Or if you want to see what kind of e-bike stuff that we've got, check out this link right here.